Bismillahirrahmanirrahim. This is the second video on Z transform, and in this video we'll be discussing example 10.2 from Mr. Oppenheim's book of Signals and Systems. So here is the question. Show pole zero plot and region of convergence for the signal. So this is the signal given. Now, before we proceed, let's clarify the concept of U negative N. So U negative N, here it is given U negative N negative 1. First of all, U negative N means that the signal starts from 0 and go towards left side up to infinity. So this will be called U negative N. But if you want to get U negative N minus 1, that means you have to move this signal further left to the point minus 1. So there is no signal here. Move left by one point, one number, then it will be U minus N minus 1. And now we straight away go to the formula for Z transform. I hope you have already learned this. If you're not, you must watch my previous video, for example 10.1. So this is the equation that we are going to use. Xn is given here. So we'll plug in that value of Xn. And now we just take the negative sign out. So this is remaining. Now we'll apply U minus N minus 1. Now U minus N minus 1 can be removed by 1 because the value is 1. We have removed it by 1. At the same time, the limit will change. The earlier limit was from minus infinity to plus infinity. And now we can see that right hand side, it will be all multiplied by 0. So our signal will only exist from minus 1 to minus infinity. So we can write the limit that from minus infinity to minus 1 is the limit for this signal. And multiplying by 1 is same as just simple this one. So we were here, and now we are trying to apply this GP formula, that if we have summation 0 to plus infinity, then x power n can be written in this form, provided mod of x is less than 1. So what we want from here is something of this form, that the limit should be starting from 0 and it should be positive limit. Here it is negative limit. So what do? We have to manipulate this, and let's see. First of all, we replace every n by negative n. Well, I could not believe it, so I ran a simple test for myself. I took an example. Let's say it is 2 raised to the power n. Just simple example, 2 raised to the power n, and the limits are from minus 3 to minus 1. So easily we can put the values. It will be 2 minus 3, 2 minus 2, and 2 minus 1. And summation of all three terms will give us 0.875. So this was if we do it directly. But as he's saying that replace n by minus n. So replacing n by minus n will, you can see we are replacing n by minus n here, here, and here. And then the minus minus cancels, so it will be 3 to 1 limit. And here a minus 1 n will remain. And then again plugging in the value, we get 2 raised to the power minus 3, minus 2, and minus 1. And we get the same answer. That means this assumption is correct. Okay, so we were here and now we replace everything by n, minus n, every n by minus n, and then minus minus cancels, cut the minus signs, so this will become, and now we can, since they are both positive, we will invert it, interchange the limits, because the lower limits is at the bottom and upper at the top. Taking common n out, so it will be like this. Still, we have not reached this point. We need n0. Here we have got n1. So there is another technique, and that is we add and subtract 1. So the answer will be like this, but again, I had doubts, so I took a simple example. Let's say it is k raised to the power n, and from limit 1 to infinity, so with the minus sign, so minus k1, minus k2, minus k3, etc. And now I add a 1 and subtract a 1, so it remains balanced. And then this 1 can be written as k power 0. So now it will become 1 minus summation of n0 to infinity. So this assumption is correct. Now for converging, this value has to be less than 1. That is, mod of a minus 1z has to be less than 1. And that means if we take this, it will be z over a, so a moves to the right. That means z mod has to be less than a. And now we can apply this formula. This formula from here, because the limit is now from 0 to infinity, and we have this value which is less than 1, and therefore we can write it as 1 over 1 minus a1z, that is 1 over 1 minus x. Our x is this value. And then we just manipulate, take LCM, simplify, and further simplify. I hope you can follow. Taking LCM, a cancels. So this answer, but we can write it properly as in this form. So z over z minus a. And just note that to define or to describe Z transform, we need to have an algebraic equation, which we have already got here. This is algebraic equation, but along with we have to write ROC. So this is ROC in our case, region of convergence. And just to carry out a comparison with example 10.1, we had the same algebraic equation there, but the region of convergence was different. Here z is less than a. In that case, z was greater than a. When we see, we discuss that point. Now let's come to the pole zero plot. Pole 0, we know that the numerator, when we put to 0, that becomes 0. So z is equal to 0 is the 0 point. And the denominator equal to 0 gives us the pole point, that is, pole is at z is equal to a. Let's go to the graph. This is the graph. Z is equal to 0, we have 0 with the red circle. And z is equal to a, we have the cross or the pole. And now what is the ROC? The ROC is less than, z is less than a. That means it has to be within this circle of radius a, less than a, and that is why we have dashed it inside this circle. So this is ROC. And again, just for comparison, in case of a and A, ROC was greater than A, Z greater than A, so it was outside A all the way. I hope you have been able to follow this. Please let me know through your comments. Thank you.